This is Amanda Kocher, and my topic for this week is insulin and glucagon. So let's start with some fuel metabolism. So this is when we are taking in our nutrients. This is how one of the mechanisms that our body uses to kind of control the uptake of those nutrients and deal with them so that our system is not overwhelmed with too much of any of these, but is also uptaking as much and absorbing as much as possible from the foods that we eat. So while there are several hormones that control fuel metabolism in humans, the pancreatic hormones, insulin and glucagon, are two that really regulate that metabolism of the organic molecules that we intake. And so just to kind of give a quick overview on each of these, insulin, which is one that a lot of us have heard of in one form or another, it is in charge of lowering blood glucose levels, fatty acid levels, and amino acid levels. Promotes storage of these molecules and also increases protein synthesis. So it allows us to, instead of keeping those molecules in our blood for longer, it promotes storage of those within other tissues. And so it is one of the key hormones that regulates how quickly we absorb and deal with our nutrients that we intake. So then glucagon, which is also a pancreatic hormone, is kind of the counterpart to insulin. So it is tasked with increasing those blood glucose levels, increasing the fatty acid levels in the body, breaking down those stored molecules so that they are available and easy to use and can be circulated quickly in the blood. But it really doesn't have an effect on the amino acids, just to kind of stay consistent with what you see on the left side of your screen. And again, it is a big player in regulating that absorptive and post-absorptive cycles as insulin's counterpart. So what does this actually look like? Within the pancreas, there are several different cell types, as you see in kind of the top center portion of this picture. But the primary cells that we are going to look at here are the alpha and beta cells. And so these cells are the cells that are actually going to secrete these hormones, insulin and glucagon, when it is appropriate. And so in the case of what's on the left, where you see an increase in blood glucose, you are going to see beta cells producing more insulin, or secreting more insulin, and circulating that in the blood to help cells uptake glucose and get it out of the blood, which effectively is going to lower blood sugar levels. At the same time, there's going to be a reduction in secretion of glucagon, and through this combination, you get normalization of that blood glucose level. This is important because as we are functioning at our highest level, we need to be in that homeostatic balance within all systems. This is just one. So, on the flip side of that, if your blood glucose or your blood sugar was to be too low, and you would maybe be becoming hypoglycemic or working towards that, you're going to have an opposite effect. So just important to remember that this glucagon and insulin balance, they are complementary to one another. They work with each other to normalize those glucose levels. So in the case where your blood glucose is lower than what is normal or okay, you are going to have alpha cells increasing the secretion of glucagon, and essentially that will help return those blood glucose levels to normal by raising your blood sugar rather than lowering it as insulin would. So what happens when the system doesn't work properly? So one of the most common endocrine disorders is diabetes mellitus, which comes in a couple forms. So there's type 1, which is also known as juvenile diabetes. This is an insulin-dependent form of diabetes. There's also type 2, which is a later onset, maturity onset, non-insulin dependent version of diabetes. And they're different because their cause is different. So when we look at type 1 is caused by those beta cells not secreting insulin. So that is that pancreas is just not, those beta cells of the pancreas are just not functioning properly. Or, in more likely case, you have an autoimmune disorder that is essentially selectively destroying the beta cells. And this kind of self-attack, this kind of autoimmune response is not something that we have a really good grasp on yet as to what, pinpointing what exactly is causing or triggers an autoimmune response that leads to type 1 diabetes. Per the name juvenile onset, it is seen more commonly in children and is not nearly as frequently diagnosed in adulthood. On the other hand, type 2 is much more common than type 1 and is also typically diagnosed in adulthood or even late adulthood. But about 98% of diabetes cases are type 2. This is caused when those target cells, so we talked about earlier in all of our endocrine system lectures about the target. Where are these hormones? What's the target organ? What's the target cell that this hormone affects? In the case of type 2, the target cells are less sensitive than normal to the insulin that's produced. So the pancreas is producing and secreting that insulin. However, those target cells have become insulin resistant in some form and therefore are not uptaking or are not using that insulin properly to then open those receptors for glucose to get into those cells. And type 2 has several factors. There are genetic factors. I know for me personally, I have a long line of type 2 diabetes in my family, so that's something that I am very aware of, even as a young person, because lifestyle factors also do play into that. In obese populations, there is a much higher rate of type 2 diabetes being diagnosed than in counterparts that are of a healthy weight in the same age ranges. So those lifestyle factors are influential, even if you have genetic factors that are predisposing you to diabetes mellitus. While these are both challenging disorders to deal with, type 1 diabetes is insulin dependent, so that is a disorder that those individuals must have insulin in order to survive. Their body does not produce it, so there's no ability for cells to uptake something that's not present. And type 2, treatments vary from oral medications to insulin to things like diet and exercise in individuals who have that option to where their insulin resistance is not to the point where it needs to be treated with medication. So this is important as young people kind of looking at your life, making sure that you know your family history, your genetic history, not just for diabetes, but for any medical condition. Make sure that you are asking your parents. Make sure you are getting that information on the genetics so that you can make the best lifestyle choices possible for you moving forward. Thank you so much for your time, and I hope you have a wonderful evening.